I will introduce the method of estimating the unreported correlations from summary statistics. This presentation is based on our publication titled Simplified Methods for Modeling Dependent Parameters in Health Economic Evaluations, a tutorial. The SARS and R code for the examples can be found in the appendices of this article. I thank my co-authors. This flowchart that outlined the context and the proposed simplified method. Correlation and covariance are basic measures of the linear relationship between two variables. In this section, methods are illustrated for quantifying the covariance and the correlation coefficients of correlated variables based on published summary statistics. We also provided an introduction to how to generate multivariate normal distribution data, a generalization of the one-dimensional normal distribution to higher dimensions, along with 3 examples: diagnostic accuracy, physician visits, and cost data with 3 components. In health economic evaluations, understanding parameter uncertainty is essential, which represents the uncertainty around the mean estimator. Based on the central limit theorem, the estimates of parameters, or transformed parameters, are often assumed to follow a normal distribution. When the estimates of parameters follow normal distributions, Pearson correlation coefficients are a suitable measure for the linear relationships between these variables. Therefore, multivariate normal distribution data is the focus of this section. The simulation of correlated data using Excel is relatively complex, but SARS and R offer user-friendly solutions for simulating multivariate normal distribution data. The syntax of simulating multivariate normal distribution data is presented in this slide. Basically, we need to provide the means of variables and the covariance matrix. After the data have been generated, the SARS dataset can be exported to a CSV file for use in other applications. Excel and TreeAge are the most commonly used software packages for decision analytic modeling. Excel users can use the index function to reference the multivariate normal distribution data for each simulation. TreeAge users can use the table function and the reserved keyword _sample, the index for the iteration being processed in the probabilistic analysis loop, to reference the multivariate normal distribution data in probabilistic analysis. Example 1 was to simulate the correlated diagnostic accuracy data based on a meta-analysis. The authors reported that the logit sensitivity was 3.55, the logit 1 minus specificity was -1.01, and the correlation coefficient was 0.64. We listed the steps for generating correlated data using the rand_normal function. This slide shows the summary statistics of simulated data, which were consistent with the parameters used to generate the data. Example 2 was used to illustrate the approach to estimate correlation coefficient of parameters. Formulae for expectation and variance for the sum of linear combinations of 2 random variables were presented in the slides. Healthcare service data are often correlated, but the correlation coefficients frequently go unreported in publications. In the current example, the sum of the squared standard errors for family doctor visits and specialist visits was smaller than the squared standard error for total physician visits, suggested that family doctor visits and specialist visits were correlated. Using formula above, we calculated that the covariance of family doctor visits and specialist visits was 0.00045. We further calculated that the correlation coefficient was 0.29. We then simulated the correlated data for family doctor visits and specialist visits. After incorporating the correlation, The mean and standard error for total physician visits, calculated using the sum of the simulated family doctor visits and specialist visits, was same as those reported in the original article. If we simulated independent distributions for family doctor visits and specialist visits, we would underestimate the variance in total physician visits. Example 3 was the simulation of various cost components to derive the total cost. In economic evaluations, instead of assigning a distribution to the total cost, we often prefer to assign distributions to the different components of cost parameters. In this way, we can understand how the different cost components contribute to the economic results. The squared standard error of the total medical costs was greater than the sum of the squared standard errors of hospital costs, physician costs, and prescription drug costs, suggesting that correlations existed among three cost components. There are three correlation coefficients in the correlation matrix. The magnitude of correlation affects only the variance of total cost. It does not affect the mean of total cost, or the mean and variance of each cost component. Because our main goal was to properly understand the variance in total costs, we assumed that the three correlations were equal. We presented the variance of linear combinations of n correlated random variables in equation 4. Under the assumption of a common correlation coefficient of three cost components, we derived the equation of the correlation coefficient. The calculated correlation coefficient was 0.334 for the three cost components. Thank you.